Alright, so I'm going to do a quick video on division, and it's kind of interesting. So if I had 35.82 divided by 4, that doesn't seem like a regular, that seems like a question, a math question, but nobody would actually ever ask. But let's say you had $35.82, and you want to divide it into 4 groups for 4 people. So if I were to take $35.82, I would probably look at it like this, $35.82. And here's where your decimal is. Now, I know that if I had 35 and I divide it into groups of 4, I could only do 8. And that would give me, well, I should probably put this off to the side. That would give me 8 times 4 is 32, and it would leave me with $3 left over. Now, obviously, I can't divide 3 by 4, but I could make that $3 into 300 cents. Now when I add that to here, I now have 382 cents. So once again, I can't do anything. The 4 doesn't go into 3, but the 4 goes in 4 goes in 38 9 times. So I'm going to put this over here. 9 times 4 is 36, and 2, and that brings down to 2. And then I can say, well, 4 goes into 22 5 times, so 5 times 4 is 20, and I get a remainder of 2. And I'm going to stop, let's see. I get a remainder of 2. If I bring down an extra 0, I'll explain that in a second. I can say 4 goes into 20 again, 5 times, and 20 minus 20 is 0, and that gives me $8.955, which doesn't really make sense, no pun intended. But if I want to round this, I would take a look here, because it's money, I'd say it means $8.96. Now, like I said, if we're going to divide this money into 4 groups, and I tried to give everyone $8.96, I'd run into problems, because you can't. But take a look at this. $8.96 is very close to $9, and 9 times 4 is $36. So that does make sense. It should have been pretty close to $35.82. So let's see what happens when I do the division algorithm. I say 4 doesn't go into 3 at all. So if you want, you put a 0 there if you'd like, but it's not necessary. And the key here, I should say this, and I'll try to do this official. The key here is trying to stay organized. And for some students, that's very difficult, myself included. So I'm going to use a ruler, but if you don't want to draw all the time, it might be beneficial just to get yourself some graph paper. And you can get 1 centimeter graph paper, and that's quite useful. So 4 doesn't go into 3, so if you want, you can put a 0 up, and then say 0 times 4 is 0, and that is a 3. And then you bring down your 5. How many times 4 goes into 35? 8 times. 8 times 4 is 32. I'm going to subtract. I get 35 minus 32 is 3. I'm going to bring down my 8. I get 38. 4 goes in 38 9 times. That's 36. I subtract. I bring down my 2. 4 goes into 22 5 times. 5 times 4 is 20. Get 2. Now, I can put a 0 here if I so choose, because 35.82 and 35.820 are the same number, and 35.8200 is the same number, and if I wanted to, I could add as many zeros as I want. So I'm going to put a 0 there, and I'm going to bring it down. I'm going to say 4 goes into 25 times, and now I have no remainder. If I wanted, I could still bring down more zeros. I don't recommend it. I can say 4 goes into 0 times, and you get a 0. And then I could bring down another 0 if I wanted, and say 4 goes into 0 times, and you see what happens. You just end up with a repeating 0. It doesn't make any sense. But you can see how the two methods are similar. I get the same answer for both. Now, I'm going to do another one. And this one's going to be a little bit more difficult. I'm going to say, what's that 27.33 divided by 2 1/4. Now, I'm going to change this question to 27.33 divided by 2.25. Now, when you do this, you end up with a question that looks like this: 2.25 divided by 27.33. Let's actually throw on another number. Let's put on a 6 on the end. Now, this doesn't look particularly good. And the reason why is because I have a decimal as my divisor. So if I want to change this into 27 and 336 thousandths divided by 2 and 25 hundredths, you can see I have a problem. I have fractions here. So if I want to get rid of this fraction in the divisor, what I can do, what I'm actually essentially doing is I'm going to multiply both sides by 100. And when you do that, this will cancel out with this, and this will cancel out with 2 of the zeros. So now I should have 27 and 336 tenths, and let's see what happens. You were probably told in school at some point in time that you should move your decimal over 2 spots. So that's what I'm going to do. I'm going to make this 225, and then I'm going to have to move this over 2 spots, 1, 2. And you can see this becomes 2,733 and 6 tenths, 0.6. And like I said, that kind of makes sense because I'm left with the 6 tenths here when I multiply by 100. What I'm essentially telling you is the reason why you can move your decimal spot over 2 spots is because what you're actually doing is you're multiplying by 100. And here I'm multiplying by 100, and that's perfectly fine. 10 divided by 2 equals 5. And if I multiply this by 100, I get 1,000 divided by 200, which is still 5. Same question. Alright, so now I'm going to actually do the question. And I'll use a nicer color. Use purple. So, I say, how many times does 225 go into... Oh, so I'm going to put my decimal point up. After I make that move, I'm going to put my decimal point up. My decimal point is still there, but we don't break that. And I say, how many times does 225 go into 2? 0. How many times does 225 go into 27? 0. How many times does 225 go into 273? Because I'm actually looking at this whole 273 here. It goes in once. 225. Then I do some basic subtraction. Let's see. 73 minus 25. That's going to be 6. That's going to be an 8. 48. I bring down a 3. 22 goes into 48 twice. So let's see. 225 should be about 2. I get 450. And sure enough, I get 33. And so now I bring down my 6. And now I say 225, that'll go in once. 225. I get a 1, 1, 1. And as long as my answer here is more than that, it means I'm okay. Now, I'm stopped, so I bring down an extra 0. And I can say, how many times does 200 go into 1,000 approximately? And that's about 5 times. Well, it is 5 times, so let's see if this works. 5 times 5 is 25, 5 and a 2. 5 times 2 is 10, 11, 12. 5 times 2 is 10, plus the 1. And you can see this number here is now too big. So I'm going to not use 5, I'll use 4. That's going to be 20. Well, 4 times 200 is 800. 4 times 25 is 100. So this is going to be 900. 0, 1, 210. And now I can bring down another 0. And that's going to go in, let's say, quite a few times. How many times 200 go into 2,100? I'm going to try 9. 9 times 25 is 225. 9 times 200 is 1,800. 1,800 and 225 is 2,025. And that gives me, let's see, 75. And you can continue on and just keep on going. It depends on how far you want around. I'm going to say 3, and that's it. Let's say 675. Oops. 675, which gives me 75 again. Oh, and look at this. Look at what happens. I could keep on going, but I'm starting to notice I'm going to end up with 3 as a repeating decimal, so my answer is 2.149, and 3 repeats, so I put the little bar over the 3. And I'm going to do one last question. Hopefully this will work. 0.03 divided by 1.24315. We'll see what happens. Hopefully this will work. Let's not use a 3. Let's use a 8. Alright, so once again, I'm going to have to move my decimal place 2 spaces over, which means I'm going to multiply this by 100. And then I have to move this over 2 spaces, which means I'm multiplying that by 100. Now that I've done that, and this is a whole number, I can put my decimal up. So now, let's see what happens. I'm going to use a nice green color. So 8 goes into 1 0 times, 8 goes into 12 once. 1 times 8 is 8. Subtract, bring down my 4, 44. 8 goes into 44 5 times. 44. Now, don't worry about the decimal at this point in time. Bring down my 3. 5 times 8 times 5 is 40. 3. 1. That's going to be a 6. 24. 7. 5. That's going to be a 9. 2, 3, and once again, you could keep on going. It depends on how far you want around. 3, 24, you get 6, and it could, like I said, you can just keep on adding on. Oops, 0, 756, and when I do, oh, that's not true. 64, I'll give this me 67, minus 64, no, and I get 3, 0, 3, 24, I get 6, so it's going to be 83, 83, 83 repeating. That's it. If you want to round to your nearest hundredth place, you look at this one and say, oh, that's going to go up. So it rounds to 15.57. That wasn't exactly what I was hoping for. Let's see if I can do 2, 1. Oh. Alright, this one will definitely work. Real quick. I'm going to make this into 0.3 divided by 2.01003. Once again, I'm going to, sorry this video is going on forever. It might be worth it though. Check this last one out. This is a good one because it touches on when you run into a problem with zeros. Once again, I'm going to move my decimal over one spot, multiplying by 10. So I have to multiply this by 10. I get 20.1003. Bring my decimal up. No times, 3 goes in 20. 6 times 18. 2, bring that down. I get 21. 3 goes in 21 7 times, so I get 21. And this is where it gets interesting. Now, 21 minus 21 is 0. I have to bring this value down. So I bring it down. Now I say, how many times 3 go into 0? Well, the answer is 0 times. 0 times 3 is 0. So I get a 0. So I bring this one down, and I say, how many times does 3 go into 0 again? Well, it still goes in 0 times. So it's 0. So now I bring down my 3. Now I can say, how many times does 3 go into 3? And the answer is once. And that's it. So now your answer is 6.7001. You have to bring up these zeros. You have to put those zeros in when the amount of times this number can go into that number. And since that number was 0, the amount of times it can go in is obviously 0 times. It happened again. How many times can you go into that number? 0 times. When we bring down the 3 eventually, it goes back to a whole number. Alright, and that's it. That's a very, very, very prolonged explanation of division. There's actually another method called the sharing method, which I absolutely think is just the bee's knees. It's wonderful, but I'm not getting into it right now. I hope you enjoyed. Thanks. Bye-bye.